Good. So what we're going to look at today is you can't do that. You have to erase that. Who did that, man? Who did that? You have to erase it. I wouldn't be able. What really? Don't do that. Who doing that, man? Good. So what we're going to look at, is my recording on? Yeah. What I'm going to look at this evening is how you can use matrices to effect geometrical transformation, right? And when it comes to geometrical transformations, we're talking about um, translations, reflections, rotations, and enlargements, right? We're going to look at all of these, how you can use matrices to perform these transformations, right? So we'll start with um, reflection. And notice in the notes, that's where we started. All right, so a moment, let me cut this. What's going on there? Yeah. So look at it. Look at this um, graph here, right? So what we have here is a point A. We have a point A, right? And we have a line y equal x. Now we are reflecting. Oh, so as I said, we're going to start with reflection, right? Reflection. So we want to reflect this point A in this line, as though the line is a mirror, and get this point. You notice A prime or the image of A, right? So you can see that if you were to reflect 4, 2 in this line, you'll get 2, 4. Now, yes, there is a geometric construction you can do with compasses, and so that would help you to get that image. But there's also a matrix that could affect that transformation as well, right? So, and the matrix is this. Let's call the matrix M. It's equal to 0, 1, 1, 0, right? And if we were to take this point 4, 2, and we're going to write it like this, 0, 1, 1, 0, and write the point 4, 2 like this, we're going to end up with, we're going to multiply, right? Rows by columns. 0 by 4 plus 1 by 2 will give us 2. 1 by 4 plus 0 by 2 will give you 4, right? So this is the matrix M, this is the point A, and this is the image of A. right? 2, 4. And that's how you get a 2, 4 there. If you have more than, you can have a whole, let's see if I can find a, if you have a whole, let's say, triangle, a rectangle, right? What you need to do is write out all the vertices of the triangle or rectangle. You can have a line segment and multiply by the matrix. I'll do an example in just a moment. So let's take the same one, right? Let's say you have a triangle, right? And this is the triangle. All right, so we call that A. All right. I'm going anti-clockwise. I know it's not normal. B, C. And I want to know what's the image of this triangle in this line here, right? When you reflect it. So this point B is going to be, all right, if this is, B is going to be 2, 0. Oh gosh, who did that one? Somebody erased the thing just now? Oh my. Did somebody erase the thing I'm writing? What is going on now? Hmm. And C is going to be, what's that? 4, 0. Oh my. What happened there just now? All right, let me move. I wonder if something is going on here that I don't understand. All right, let me see if it can work fine. You know what? I can't use this whiteboard. Something is going wrong with it. Let me use another whiteboard. You're seeing this, right?
Yep.
All right. So what I want to show you is if you have an entire triangle, you want to, let's say you want to, right, we'll leave that as A. I'll call this B, call this C. So B is going to be 2, 0. C is going to be 4, 0, right? And I want to find the image of this triangle in this line, right? So what I'm going to do, I'm going to take um, the matrix 0, 1, 1, 0, and I'm going to write the vortices of this triangle as another matrix, right? So A, B, C. And this is 4, 2, B is going to be 2, 0, and C is going to be 4, 0, right? And let's multiply and see what happens. Rows by columns, right? So basically what this will do, 0 by 4, 0, 1 by 2, 2. We go there. 0 by 2, 0, 1 by 0, so you get 0 there. And then you go 0 by 4 plus 1 by 0, 0 there, right? And this row by each column then. 1 by 4. Basically, what will happen, you have 4, 2, 4, right? That's what we want to have. And this is the image of A. We got this already. This is the image of B. And this is the image of C. And if you were to draw this, so we got 2, 4 here already. We want 0, 2 now. 0, 2 is going to be here. That's going to be B prime. And C prime is going to be 0, 4, which is there, right? So it does look like the image, right? It does look like the image. So you could actually effect a reflection in a certain line by simply taking the matrix. There's a certain matrix associated with, and there's some standard ones. I'll give you in just a moment, right? And you write the vortices. In this case, if you're dealing with a triangle, you could have a square, you could have any shape. And you put the vortices down like it's a matrix, and you multiply the transformation matrix, which is this here, right, by the vortices of the triangle or rectangle or square or whatever, and you get the image over here. This is some of them, the standard matrices. I'll give you them. Let me move this aside. Yeah, so this is the one we used just now, a reflection in the line y equal x. This is the one we use. But then you can have the line y equal minus x, right? That's the line, if I were to write it, y equal minus x is this line. Just now y equal x was this line, right? This is y equal x. This is y equal minus x. The y-axis, well, you know what the y-axis. This is the y-axis here, right? And the x-axis. So these are the matrices that'll do it for you. These are kind of standard matrix. So if I give you the vortices of some shape, and I say, perform a reflection in the y-axis, you take this one, and you multiply the vortices. If I say perform a reflection in the x-axis, you take that one, you know? Are you following that?
Yeah, yes, sir.
It
Yes.
should be difficult. let's talk about rotation now. Rotation. And again, there are matrices that will effect a rotation for you, right? Um, I will just give you the matrices, right? There are some standard ones. Yeah. So if you were to do a rotation of some point or object, 90 degrees clockwise, you use this matrix. If you want to do a 90 degrees anti-clockwise, and you know what's clockwise? Clockwise going this way. Anti-clockwise is going that way, right? And well, when you say 180, you don't have to stipulate clockwise or anti-clockwise. It's going to be the same thing. And just to give you an example, I'm bringing over an example now. Good. So look at this one. So you have a rectangle here. Oh, sorry. This is the original rectangle, right? So you have points like, all right, let me go with, you want to say this is O, A, B, C, right? A is the point, okay, O is the point 0, 0. A is the point 2, 0. B is that point 4, 2, and C is the point 4, naught, right? And we're going to rotate this 90 degrees clockwise. You can see that, right? Good. So the matrix for a clockwise rotation of 90 degrees, clockwise 90, is this matrix here. 0, 1, minus 1, 0, right? And we're going to multiply it by A, B, sorry, O, A, B, C, right? Let's see. So 0, 0, A is 2, 0, B is 4, 2, and C is 4, 0, right? I think we need some more space here now. Let me come. Yeah, it's good. So we're multiplying. So what you see happening here really? 0 by 0 plus 1 by 0, you get 0. Basically, it's like you're putting this on top. 0 by 2 is 0, 1 by 0 is 0, right? 0 by 4 is 0, 1 by 2, you get 2, and you get a 0 at the end, right? I kind of skip this step. How it happens? Good. What about here now? Minus 1 by 0 plus 0 by 0 gives you 0. Minus 1 by 2, it's like you're changing all these numbers. Minus 2, minus 4, minus 4. Right? So O prime, A prime, B prime, C prime, right? So O prime is 0, 0, that's this point here. A prime, that's this point is transformed to here now. This is A prime, which you can see is 0. Did I do that right? Uh, I think I get that one wrong. Um, 0. Oh, did I get that one? I will suppose this point supposed to come here, which is 2, 0. This is 0, 2, man. This is 0, A, 0, 2. Right? So this is 0, 2 here, 2. So this is supposed to be 2 here. So this got to be 0 here. I hope I haven't confused the whole class now. This is 0, 2. Right? So this is going to be 2, 0 here. Right? So indeed we see is A prime is 2, 0, right? B prime is okay, B prime, and C prime is 0 from here. C prime is 0 minus 4, right? Check it back. You can always check it back to see that it's correct. This is a clockwise rotation of 90 degrees, and this is the matrix that will do it, right? Following me? You all follow the multiplication and so how I did it?
Yeah.
Rows by
Got it.
column, rows by columns, rows by columns, rows by columns. That's how you get all these top numbers. The bottom row by each column will give you the bottom numbers. The top row by each column will give you those top numbers, right? 0 by 0 plus 1 by 0, 0. 0 by 0 plus 1 by 2, you get 2. 0 by 4 plus 1 by, did I get that right? Is this right? 4, 2? Where is supposed to be a 0 here? No. 4, 2 is there. 4, 2. Yeah. 0 by 4 plus 1 by 2 gives you 2. 0 by 4 plus 1 by 2 gives you 0. What did I say? 0 by 4 plus 1 by 0 gives you 0, right? Similarly here, minus 1 by 0 plus 0 by 0, that gives you that 0. Minus 1 by this 0 plus this 0 by this 2, all gives you 0 again. Minus 1 by 4 plus 0 by 2 gives you the minus 4. Then minus 1 by this 4 plus 0 by 0 gives you minus 40. Right? And this is basically the image, this image here, of this original rectangle that you rotate. When you rotate it, you get this here. So you can actually do it using a matrix. All right. You can do it also with enlargements. Enlargements, right? And for example, let me just bring a diagram for you. It's all in the notes, huh? The notes I gave you.
Yeah, looking at the notes right now, it's here. Enlargement.
Yeah, yeah. So let's say you take this object here, right? This object. I think they should put in OR. They put A there, man. Let's still put B here. It's so silly. Uh, all right, let's go with B is 0, 2, and let's call this C. So O is 0, 0. Um, C is 4, 0, right? Good. So if you enlarge this to this bigger rectangle here, your image is going to be okay. So B is going to go up here. B prime is going to be what? 1, 2, 3, 4, 0, 4, sorry, 0, 4. We got that already. This A becomes that. Well, the origin remains the same, and here is C prime. C prime is going to be 1, 2, 3, 4, 5, 6, 7, 8, 8 naught, right? Again, the matrix that will do that is of the form, all right, it's of the form K00K, right? K is what we call the enlargement factor, right? The enlargement factor. So what we could do with these points is we could take this here, because it seems as though the enlargement factor is 2 here, right? K is equal to 2 in this case. Doesn't it seem that way? Everything seems to double. So you put 2, 0, 0, 2, multiply by, well, the origin O, 0, 0. Let me go with A. A is 4, 2. B is 0, 2. And C is 4, 0, right? So we're going to multiply that. See what happens. And basically what happens is you're simply multiplying um, each of these numbers by 2, right? So 2 by 0 plus 0 by 0 is 0, right? That doesn't change. 2 by 4, 8, 0 by 2. So this becomes 8. This becomes another 0. That becomes 8. The bottom here, these numbers are multiplying now. Right? And see. So O prime, A prime, B prime, C prime. Right? And indeed that is so. Oh my, all right, let me make it smaller. All right, look. O prime is the origin. That doesn't move. Right? That didn't move here. A prime, 8, 4. B prime, 0, 4. C prime, 8 naught. Right? Let me see that there. Good. So let's move away from these and we go to translation, or the last one. Translation. Now, a translation really involves either a vertical, a horizontal, or both a vertical and a horizontal movement of a point, right? Again, let me give you an example. So let's take the point A here, and let's say this is A prime. So what has happened here is like this point has moved 3 units this way and 2 units that way, right? Here, 3 units to the right and 2 units vertically up. So you can actually describe this translation as equal to 3, 2, right? You can describe it like that. And to get the image A, right? So A prime is going to be equal to T plus A, which is equals to 3, 2 plus 4, 2. And you get what? 7, 4. And if you're dealing with an entire object, you know, like, okay, let's say, or a plane figure, like a triangle or a rectangle, the only difference here is don't write, like if you have a triangle, let me just say, right? Let's say you have a triangle, O, A, B, right? Let's say this. And you're translating it. So this is the origin, 0, 0. A is 2, 2, what am I writing on? 0, 2. The x value gonna come first. And B is 2, 0, right? Good. So I want to translate it using the same translation here. Now, what we don't do is this. Don't write 3, 2 plus and write the whole matrix like this. 0, 0, okay, that's O, and A, 0, 2, and B as 2, 0. Don't do this. Don't do it. Why? Anybody knows why? Hmm? Anybody can remember our discussion about adding two, when you add two matrices, what's the condition that is necessary before you can add two matrices?
So rows and columns.
What about rows and columns? There's a condition before you can add two matrices. They must be of the same. Before you can add them, they have to be the same what?
Dimensions.
Correct, right? So this is not the same as these two aren't the same. So what you got to do, you got to take each one of these, take 1, 1 vertices of the triangle. So you take 3, 2 plus 0, 0, and you add them up, right? You understand? So T plus O gives you O prime. Again, 3, 2 plus A, which is 0, 2, 0, 2 would add up to give you 3, 4, right? Then 3, 2 plus B now, which is B is There's something blocking it here. D is 2, 0. You add them up and you get 5, 2. Right? You have to add them individually. That's the difference with translation. With the others, you could have multiplied all together. But in translation, the rule, the rule for adding matrices is what stands in the way. So you have to do them one by one. Right? So your image OA prime B prime are these here. Right? You can write them back as let me put it here. Your image is really O 0 0 A prime 3 4 B prime 5 2. Right? That's the image of that triangle we had earlier under the translation 3 2. And we can actually draw it back if you want. You move it 3 places this way and 2 up. Let me chop some of the examples from the notes. Oh, this is actually a CXC question. Let me bring it. Let me take this piece. I'll get into the whole thing. Look at this one. So you have a triangle XYZ. These are the coordinates. And it's mapped onto its image, X prime, Y prime, Z prime, by this transformation. You're to calculate the vortices of X prime, Y prime, Z prime, right? So you simply take this matrix, write these 3 vortices as a big matrix and multiply them, right? And that's what they do it one by one, right? I wouldn't do this. They do it like this. Let me just show you what they do. They took each point and multiply it, right? You don't have to do it. You could do it like this. -1, 0, 0, 1 times 4, 5, -3, 2, -1, 4. You multiply this, and you should get this exact point. -4, 5, 3, 2, and 1, 4. Right? So this is the matrix M. This is X, that's Y, that's Z. This is X prime, this is Y prime, this is Z prime, right? Yeah, somebody is unmuted. So if they're yeah. Right, so you can do it at one go. Multiply everything at one time, rather than how they did it here. Some of them are more involved in that you can do two transformation on a particular object, like you have X, Y, and Z here. You do two transformation. Let me see if I can bring one of that. All right, let me give you this part. And these are CXC level questions. That's why they seem like, you know. Oh, some mosquito getting a room here, huh? And I have mesh on the wall, on the windows, you know. But I think they might be coming through. Or maybe they were trapped in here earlier. Okay, good. So notice they want you to write down the matrix M subscript Y, the reflection that represents reflection in the y-axis. Anybody can say that? Which one is it? You have to, and at CXC, you have to memorize these things. Eh? You have to know them. What's going on? Right. So the first one, the matrix that represents reflection in the y-axis is this one here, right? The matrix that represents a rotation of 180 degrees about the origin is this one here. As I think I gave you these, right, in a table earlier. Good. Here what they say now. What's going on here? Yeah. Determine the single matrix U that represents a transformation MY followed by another transformation RL. Right? So if you're going to do this one first and this one second, what you could do, you could come up with a single matrix that will do both. So what you do, you put MY on the inside here, and you put RL down here and multiply them. And this matrix is going to do both of these. It is going to do this followed by this. Right? So that single matrix can effect two transformations for you. Right? So this is a tricky one. So you're going to get a few more. You can see a few more in the notes that I sent to you. All right? Some of them involve some graph work and so. So that's the trouble. We don't have a way of drawing graphs with our hands, you know, on Zoom like this. It's very difficult. As a matter of fact, when I have to do work for CXC, to draw graphs on the computer by hand is be very difficult for me. Right? Yeah. So that's a little introduction there. That's a little introduction there to matrices being used in effecting geometric transformations. Right? So what's going to happen there? I think we covered everything that we have to cover on matrices. Right? We're going to stop there. And what I'll do, I'll try my best during this week to send you some work that you'll have to do to present for me next Monday. Now, Friday coming, we wouldn't have a class. I have a meeting around 6 o'clock that day that I have to be at. So we wouldn't have a class Friday. However, that will give you an opportunity to work on the assignment I'm going to send you, so that come next Monday, you're going to present the question that I sent to you, question or questions that I sent to you. You're going to present it to me, right? And it's going to cover the last few topics that we did. Is that clear?
Yes, sir.
Yes, sir.
Yes,
All right.
sir.
Yes, sir.
Good. So I'll stop the recording here.